SQL is a language of tabular data. It started as a query language for relational databases, but it's now used in data analytics tools like Apache Spark, as well as other systems like the Kafka Distributed Stream Processing Platform. So why is SQL so popular? The short answer is that it's well suited for working with tabular data. Much of the data we use lends itself to tabular structures. Retailers track customer data in tables. Healthcare companies manage patient data with relational tables. In fact, it's hard to think of an industry that couldn't make use of SQL and tabular data. Another reason SQL is popular is that it's declarative. We specify what we want without having to concern ourselves with how to get what we want. For example, we can state what columns we want to retrieve and then filter the resulting set of rows by some condition. The results of our queries are tables, and we can use SQL to query the results of other SQL queries. Now, I should point out that there are statements that can result in output that's not strictly tabular. For example, some commands that have been added to recent versions of SQL to support rollups, cubes, and other structures that are useful in reporting. If you're a developer, you're probably used to using procedural languages. In languages like Java, Python, and C++, you specify how to do something. For example, you might specify how to loop through an array. In procedural languages, you directly manipulate data structures and perform operations in an order that you specify. SQL statements have to be mapped from their declarative form into a procedural form in order to return the data that's specified in the query. The procedural version of a query is known as an execution plan. It's a sequence of steps that can scan, filter, and join data in such a way that when the execution plan is done, it produces the output that you specified in your declarative query. When we develop procedural code, we're often thinking about how to make it efficient. The same thing applies to execution plans. While there may be many ways to execute a query, some are more efficient than others. For example, if you want to return data about a subset of customer purchases where the customer ID starts with the numbers 3014, you could look through all the rows in a, say, 10 million row table, but that's quite inefficient. A better approach is to use an index which points to the location of the data blocks containing the rows you're interested in. In this course, you will learn about query plans and the different kinds of steps that are used in execution plans. We will discuss the trade-offs of different ways to map from a declarative query to a procedural execution plan. And perhaps most importantly, we'll learn techniques for structuring your data and crafting your queries to produce efficient execution plans.